All right, ladies and gentlemen, let's get started. You have used the zero product property to solve factorable quadratic equations. You can extend this technique to solve some higher degree polynomial equations. Example 1. Solve 5x cubed minus 40x squared plus 80x equals 0. Okay, so again, look at this. It looks like, well, I have an 80, I have a 40, I have a 5. It looks like I can factor out a 5. And it looks like it can factor out an x. So when I do that, what I have left is x squared minus 8x plus 16 is equal to 0. Okay, now I'll tell you the x squared minus 8x plus 16 is a perfect square trinomial. Again, but let's go ahead and do it. So I'll have an x and I'll have an x since my coefficient is 1. Again, remember, I look at that 1, and if that's positive, I look at that 1. So that will tell me that they both have to be negative. So if they're both negative, what are factors? And when I multiply them, give me 16. Yeah, when I add them, give me negative 8. And you would tell me it's negative 4 and negative 4 is equal to 0. Or, like I said before, we can write that as 5x times x minus 4 squared is equal to 0. So now remember, according to the zero product property, this is being multiplied to that. So by the zero product property, we can say that 5x is equal to 0, or x minus 4 squared is equal to 0. If that's the case, then on this one here, if I divided by 5, I would get x is equal to 0. On this one here, think about it. To undo a square, I would square root it. The square root of 0 is 0. So x minus 4 equals 0. Or in this case, we would say that x is equal to 4. And those are our two answers. Now what we should notice here in this case, that x minus 4 appears more than once. This creates a repeated solution of x is equal to 4. Since it appears twice, the root x equals 4 has a multiplicity of 2. If we saw x minus 4 3 times, it would have a multiplicity of 3, and so on. In general, when a factor x minus k of f of x is raised to an odd power, the graph crosses the x-axis at x is equal to k. When a factor x minus k of f of x is raised to an even power, the graph of f touches the x-axis but does not cross at x is equal to k. All right, so I'm going to give you just one example here. And our next example, find the zeros of f of x is equal to x to the 4th minus 18x squared plus plus 81, Then sketch a graph of the function. All right. So now remember, I showed you a little way to look at stuff, and one of that was substitution. So if I let u equal x squared, then I will get u squared minus 18u plus 81 is equal to 0. Okay, so if that's the case, then again, I'll tell you right now, that is a perfect square trinomial. So I can say then that u minus 9 squared is equal to 0. So I oversimplified it. But again, remember that u was equal to x squared. So what that tells us is that I have x squared minus 9 squared is equal to 0. So now let's kind of simplify that one and you'll see what happens here. So if I simplified that one, I would get x squared minus 9 times x squared minus 9. And again, we're setting that equal to 0. Now in this case here, what do I have, ladies and gentlemen? I have a difference of two squares, a difference of two squares. So this one here I can write as x plus 3, x minus 3 for the first one. And for the second one, I can write that as x plus 3, x minus 3 is equal to 0. Now what I want you to notice here, now I have an x plus 3 there, and I have an x plus 3 there. So now I can write this as x plus 3 squared, and then I have this one here and this one here, which I can write as x minus 3 squared is equal to 0. All right? So now, since both of them are raised to even powers, we know that the graph will touch the x-axis at x is equal to negative 3 and x is equal to positive 3. All right, so now I'm going to go ahead and graph it for you. So on the x-axis, I just went ahead and I went by 1 and negative 1. So now, remember, at the beginning, our c is 81. So that is our our y-intercept. So I went ahead and I went by 20s here. So 20, 40, 60, 80. So 81 will be right there, right? We know that one of them is at negative 3, one of our x-intercepts, and our other one is at positive 3. Okay, so now what we're going to do is we're just going to go ahead and connect our dots. Now remember, we talked about in behavior earlier in the chapter. Remember, if they're even, they're both going to go up or they're both going to go down. Oops, sorry, going the wrong way. All right, they're going to both go up or they're both going to go down. The one in the book has a negative a, so it has negative x to the fourth. This one here is positive, so we know that they're both going to go up. So knowing that, our in behavior, we're going to have something that ends up looking like this. Now remember, it said when it was even, it touches the graph, but does not cross. All right, so it looks like we have a nice W there, going at you. And again, that's it. Remember, if it's odd, it would cross it somewhere. All right, so, and well, we'll see that more as we go along. So this one here would be like if it was odd, it would cross there. But we don't have an odd one here. We just had two even ones. All right, so let me go ahead and erase that one because we didn't need it. And I am done. Thank you.